Hello, sports fans. Let's talk today about the atom. Maybe I think most of you probably know, but let's just ask the question: what is an atom? Um, there's lots of ways to say it. The best way that I've come up with is it's the smallest particle of a pure substance, and that may not make sense right off, but let me kind of elaborate. So, if you take a piece of coal, piece of anything. Let's say we take frozen oxygen and you break that in half. And you've got this frozen oxygen piece. Would you say at this point that this is still oxygen? If this was oxygen, you cut it in half, would you say this is still oxygen? I think you would. So let's cut it in half again. Now we've got it up over. Is this guy still oxygen? I mean, he still comes from here, still looks the same, feels the same, does all the same stuff. I would argue that it's still oxygen. And if you broke it in half again, and again, and again, until it got to a tiny little dot, would this little dot still be oxygen? I think it probably would. Okay, if it's still the same boiling point, freezing point, same properties, I think you'd still call it oxygen. Well, eventually you're going to get to a point when you keep dividing this smaller than we can see, you're going to get it to where when you do break it apart, it's no longer oxygen. It doesn't do what oxygen does. At that point, it's an atom. An atom is that smallest little piece of something that is that something, I guess, is the easiest way to say it. Okay, hopefully that makes some degree of sense. If it doesn't, I apologize. But that's what an atom is. Now, let me kind of talk about the next part. What's the structure of an atom? Okay, let's get these out of the way. I bet this is review for some of you. Okay, the structure of an atom. It turns out an atom has some things we need to know about. It has three parts. It has protons, it has neutrons, and it has electrons. And there's two places in the atom that we need to know about: nucleus and shells. Okay? So let me bring my picture of the atom up here. This happens to be an oxygen atom. And really, a lot of times they try and teach this using a hydrogen atom, which has one proton, one neutron, one electron. That's it. And maybe that's the way to go. I don't know. But I like this because this is something we're going to use a lot more. And it shows all the different parts. So let me kind of label the parts for you. Right here. Let's see. Right here. This is a proton. This is a neutron. Okay, this, where they're found, is the nucleus. Okay, it's a nucleus. And it turns out that the nucleus, I want you to remember this, a nucleus is a place, not a part. Okay, so you might say the tree is at Drury, but you wouldn't say Drury is a part of Drury. You would just say Drury is a place and the tree is the part. Does that make sense? Okay, I hope so. Outside here, kind of rotating around these yellow things, are electrons. Now, in my drawing, I've got the electrons way, way, way too big. It turns out that electrons, if this is a proton in size, electrons like that. Much, 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 much smaller. So, but just to make it clarified on this picture, I've made them bigger. Now, these electrons move around the nucleus. They orbit around it, just circle around it, on these things called shells. And so shells is another place, okay? And different atoms have different numbers of shells. You take hydrogen or helium, and they have one shell. You take lithium or oxygen, which this is, or carbon or nitrogen, and they have two shells. But you take something like uranium, and it has 9 or 10 shells, has lots of shells. So it just depends on how many electrons it has, tells us how many shells it has. It turns out that these electrons out here in the outer shell are called valence electrons. And I'll write that right here. Valence, whoops, sorry. Oh, whoops, let's go there. Valence, my cord's in the way, that's the problem. Okay, valence electrons. That is these outside electrons, okay? So far we have talked about what an atom actually is, and we've talked about the structure of an atom. Now I want to go into a little bit more detail about protons, neutrons, and electrons. Okay, so in this column I'm going to put the different types of subatomic particles that make up an atom. Here's the last thing I want to say about protons and neutrons and electrons. Well, not the last thing, but here's the one other really big thing I want you to remember. See these shells? I told you these are valence electrons, and here's another shell. It turns out that these shells need to have a certain number to make the atom happy. Okay? If it only has this first shell, then it needs 2 electrons. Okay? It needs 2 electrons to make it happy. So the first shell, 2 electrons. Second shell, this one out here, needs 8. When it has that many, the atom is what I call in Happyville. You'll hear me say that a lot. Okay? That just means that the atom is satisfied and is not really looking for any electrons or trying to give away electrons. It's really happy. In this case, oxygen, if you look, only has 6 valence electrons. It has 8 total, but only has 6 valence electrons. It needs 8 valence electrons. It is not in Happyville. We will talk about how it fixes that later. But for right now, understand that to be in Happyville, has to have 2 and then 8, and then the rest of them 3 on to whatever is 8. Okay? All right, so that's kind of that section. And now I want to talk about an element. What exactly makes up an element? Okay, in simplest terms, an element is just 2 or more atoms of the same type of atom. So 2, if I had this, and I then had 2, that's an element, okay? If this was a different atom and we had 2, that's called a molecule. But if they're the same, it's called an element. You got it? All right, cool. Now, it turns out that there's about 100 and, well, I think there's 118 known elements, but not all of them are natural. And I can't remember exactly how many natural ones. I'd say a little over 100 natural elements that exist in the world, the known universe, really. And here they are. They've been organized in a nice system. And here's kind of a close-up of this, okay? And what this is telling us is it tells us quite a bit. The first thing is each element has a chemical symbol, and it's usually 1 or 2 letters, okay? No more than 2. So 1 or 2 letters. That's number 1. The second thing is you get this number right here. Let me circle it for you. Let's see. This number is what's known as the atomic number. Now, here's the interesting thing. An atomic number is the number of protons that an atom has. And that is what decides what kind of atom it is. So if it's an oxygen atom, it has 8 protons. Okay, if it has 7 protons, it's nitrogen. If it has 3 protons, it's lithium. Okay, no matter what. The protons always stay the same, but the neutrons and the electrons can change, and we'll talk about that in just a second. So atomic number. Okay. The second thing that this whole thing tells us is it tells us this mass. Okay. It tells us the mass of the atom. How big is the atom? So this oxygen atom has a mass of 15.9994. That is 16 times more than that, right? So that's a much bigger atom than this, which kind of makes sense. If you look and all we had was one red dot, one blue dot, one yellow dot, that's a lot smaller atom than this guy that has 24 different subparticles. Okay. Now, why doesn't this just say 1 or 4 or 6? Because here's how you figure out this mass number. All right, mass number. All it is it's the protons plus the neutrons, okay? That equals that, okay? All right, well, so shouldn't that be a whole number? Here's why it's not a whole number. Let me get rid of this real quick. Boom. Give me a little room to work. Okay, so the reason, excuse me, is it turns out I told you protons are always a set number per atom. But sometimes, let's take hydrogen. Hydrogen has one proton, so it should have one neutron and one electron. Should be 1 to 1 to 1. But sometimes, when there's one proton, sometimes there's two neutrons. Or sometimes there's no neutrons on a hydrogen atom. Okay? There's different amounts. These things are called isotopes. When the neutron is different, it is called an isotope. When the neutron is different than the proton, it is called an isotope. Write that down, sports fans. Okay? Just to kind of keep us going here real quick, when the electrons are different, so one proton, if we have two electrons instead of one electron or no electrons, this is called an ion. Okay? And we're going to talk about charged ions later. But for right now, you need to know the difference between an isotope and an ion. An isotope is extra or fewer neutrons than protons. An ion is extra or fewer electrons than protons. Is that clear? Okay, no one's saying no, so I'm going to keep going. All right, let me clean this up. Okay, so going back to the mass number idea, the mass number is the protons plus the neutrons, and that makes, sometimes it's real straightforward, and sometimes you have these isotopes. Well, if you figure that count the proton as 1 and count a neutron as 1, or no, I'm sorry, let's count the proton as a half and the neutron as a half. 0.5 plus 0.5 equals 1, okay? That's where that 1 comes from. But like I said, isotopes are different. So if there's two neutrons, let's write over here. One proton is 0.5. It's pretty crappy. There we go. Plus, now two neutrons, 0.5 and 0.5 is 1. So is 1. So this particular isotope has a mass number of 1.5. Well, when you average all of the possible isotopes for an element, that gives you this number, which is actually called the atomic mass. Okay? So that number is an average of all the mass numbers of all the possible isotopes. Capiche? All right, good. We're almost done here. Let me show you a couple other things. Turns out the way this is organized is it goes by atomic number, therefore it goes by the number of protons. So you got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, so on. Okay? The reason there's gaps here is they organize this by the number of valence electrons in the outside shell of the atom. So this column, let me get over there, this column right here all have one valence electron in their outside shell. This column, well, has a full one. This is 2. This one, this has 8. This has 7. This has 6, 5, 4, 3. And then these are a little different, but it's the same basic idea. How many valence electrons are in the outside? The reason they put them in the same column is it turns out that the ones in the same column typically have very similar physical properties. So they have the same boiling, not the same boiling point, but the boiling point is close. The freezing point is close. Excuse me, the melting point is close. All those things are close in a column, okay? And that'll become important later. All right, so let's make sure I've gotten everything I need to say down here. Talked about all the mass numbers and all that. We've talked about isotopes and ions. We've talked about the basic organization of this periodic chart. It's also broken into areas, metals, non-metals, different stuff like that. But I'm not at all worried about that. Ignore that for right now. We've talked about the rows and the columns. I think we've covered it, guys. And, of course, we talked about, and maybe this is going to be the most important thing, we have talked about how electrons and protons are attracted to each other because of their opposite charge. That's really important to remember. Okay, I hope you get it. If you haven't, please watch it again or ask me questions in class or go to the Prezi. All this information is on the Prezi. All right, have a great day. Peace out.